definitely ask questions and review, and I think it'll be okay. Beside this lesson here, the rest of it is all review anyhow. Okay, matrices. Ooh, what are they? What are they? A matrix is simply a rectangular array. Some say a rectangular array of numbers, and you can write of numbers if you want. But I prefer the shortened version, just a rectangular array. So if you look really off to the right here is the matrix. Off to the right is the actual matrix. When you guys get to Algebra 2, we'll deal a lot with matrices, but we do like to introduce it to you in Algebra 1. All right, so what's the analogy? Let's suppose I made up a spreadsheet. How many of you guys have ever made up a spreadsheet, computers or whatever? Okay, maybe for a science fair. So I made up a spreadsheet here. I got HCS beverage supply, and we've got Coke and Sprite and Mountain Dew, and I just made up some numbers of how much is in the closet, how much is in the machine, and how much is to order. And you'll notice then that the matrix corresponds to the spreadsheet. It's pretty simplistic. The top row would be the closet, right? And the first column would be the Coke. The second column would be the Sprite. The third column would be the Dew. The first row would be the closet. The second row would be the machine. The third row would be the order. Pretty simplistic. A matrix. So it's a rectangular array. A lot of companies today use very complex matrices involved with all of their supply and stuff. Are matrices just for supplies? No, they go way beyond that. A lot of anybody in here into programming yet? Have you made any arrays? Have you figured out the beauty of an array and how once you have an array, you can then use it and modify it a little bit to make it do all kinds? Well, you will if you keep programming, because arrays are just magical in programming, and you can make one and therefore save you all the time it took you to make that one array. Every time you need to just change a little something with that thing, you just change the array a little bit. You multiply it, you divide it, there's just a bunch of things you can do with arrays. So there's a lot of applications. The most simplistic one is in the idea of stock and such like that. All right, so every matrix is made up of rows. So take your red, and of course these are the rows. And then columns. Now, some of you, for some reason, can never keep straight what a row is and what a column is. All right, I can't help you there. Okay, I just can't help you. Probably somebody in the past had told you that houses have those columns, and they go this way. But you can't get them confused. You can't call the row a column, and you can't call the column a row. So if you keep getting that confused, get it settled in your brain somehow, some way. Because you don't want to flip them, right? Rows are horizontal, columns are vertical. So we have 3 rows to this, and we have 3 columns. Matrices are described by their rows and columns. Matrices are described by their rows and columns. Hence, take your red. Because we have 3 rows, we have a 3. And because we have 3 columns, we have a 3. This is a 3 by 3 matrix. So if somebody said, hey, describe the matrix, you'd say 3 by 3. You'd say 3 by 3. Okay, the X is said, you use the word by, right? You don't say it's a 3x3, all right? People will think that person doesn't know what they're talking about. It's a 3 by 3, all right? So a couple examples. Go ahead and through and see if you can do A, B, C, and D. Describe matrix A, describe matrix B, describe matrix C, describe matrix D. If you want to, you can look up here, See if you're getting them correct. Again, don't look unless you need it. And hopefully you went 4 for 4. Doing rows, columns. First one has 3 rows and 2 columns. Second one has 2 rows and 3 columns. Third one has 1 row, 4 columns. And then the last one has 2 rows and 1 column. Right? By the way, C is called a row matrix. Whenever the matrix has just 1 row, it's called a row matrix. Therefore, D would be called a column matrix because it has just 1 column. Right? So row matrix, column matrix. All right, not only that, but elements are located by their row and column. Elements, which are the individual numbers, are located by their row and column. And we do a subscript system. So you can see the A has a subscript of 31. Row 3, column 1. Now you're supposed to know that. So look back up at the A matrix. And what element is in row 3, column 1? And you would say, look at the A matrix. Row 3, column 1 is the -8. Row 3, column 1 is the -8. Everybody can do that. Okay, so do the B sub 12. What element is B sub 12? By the way, notice we're using lowercase letters with the subscript. That means we're looking for an element. What is B sub 12? Say it on 3. 1, 2, 3. No, 3. Yes, 4. All right, good. First row, second element, right? First row, second element. All right, give me C sub 11. Go ahead and find C sub 11. And the answer is? And let's finish off with D sub 21. And the answer is 1. Second row, first column. There's only 1 column, so second row, and it's 1. All right, you got that? That's not hard, right? You can remember that? I will ask you a question like that come test time. I will definitely ask you to describe a matrix come test time. All right, now, oh my, adding matrices will never, ever, ever be able to add or subtract matrices. That's going to be way too hard. It's going to be impossible, Mr. Scarfi. Because matrices are so mysterious and spooky. All right, that's not a good ghost, but you can throw one in there. They're not. Look. All right, so maybe you don't understand all of what matrices are, but I got to tell you, to add them is really, 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 really easy. To add matrices. Add elements in the same location. Gee, that's tough. However, there is one thing. You can only add matrices if they are the same dimensions. The dimensions of the matrix has to be the same. You can only add a 3 by 3 and a 3 by 3, a 2 by 5 and a 2 by 5, a 1 by 7 and a 1 by 7. Because you got to have an element that matches up. So look how tough this is. This is really hard. So watch. Top left, row 1, column 1. Row 1, column 1. 5 minus 2 is 3. Adding matrices is really hard. It's really hard. I'm scared. All right, you want to keep working down the row? Let's keep going down the row. Here, I'll use black. 2 plus 3, 5. Ooh, scary. Right? second row or first row second element. And here I'll go green. 2 plus 4. 6. Is this algebra 1? No, okay. All right, and then finish it off. Finish it off. Just don't make a stupid mistake, that's all. Finish it off. Gee, that was hard. Can we do that? We can do that. We can do that. Adding matrices. Oh no, subtracting matrices. Surely we would have no idea. All right, look at the blank. Don't say anything yet. To subtract matrices, blank the negative. On 3, give me a word that you think might go there if you got an idea. Here we go. 1, 2, 3. All right, let me try it. Well, I think I heard it once only, which surprises me. Okay, matrices are spooky. What would you do in any other situation like this? What would you do to the negative? You would? If you guys can't apply what you've learned to other situations, you're stuck. You got to distribute. Come on. Any other time you got a negative in front of something, you're going to distribute. So you got to distribute the negative and then add, right? Just like any negative in front of a parentheses. You got to distribute the negative. So look, this negative's got to go everywhere. It's got to go everywhere. Now, some of you can do this in your head, a few of you. Be careful. But let's just show what the new matrix is when you distribute the negative. The second matrix now becomes -5, -2, -2, +3. Was that original 6? Yeah, -6 and -6, right? You just change the sign of everything in the second matrix and then add them up. No different than if we had a negative in front of a parentheses, right? Don't let the fact that it's a matrix say, I have no idea what to do. Listen to what I'm saying. All you do is change the sign of everything in the second matrix. Look, if you're just looking to copy something off the board and you're not listening to my words, you are not learning the concept. You are, and I see some of you just copying off the board. Listen to what I said. Take the second matrix and change the sign of everything in it to the opposite sign. That's all we did. That's distributing the negative. Now let's add these two right here, right? Now add these up. So go ahead and just add them up. Look at the numbers. Add them up. You know how to add. Just look at the numbers and add them up. All right, this is like pre-algebra, day 1, day 3, adding positive and negative numbers, right? So don't let the spookiness of a matrix scare you off. It's not a big deal. All right, how many got -7, 1, 2, 7, -8, -9? All right, so again, you're just adding them up, okay? Don't make that hard. Okay, one other thing, scalar multiplication. Ooh my. Ooh my. Hey, guess what? Distribute the coefficient. It's just like it's out in front of a parentheses. See this -4 out front? This is what's called scalar multiplication. Real simple. What's -4 times 5? -20. So guess what? That goes in that spot. I'm going to work down the first column, all right? What's -4 times 2? -8. What's -4 times the bottom 2? -8. Let's work across now the second column. What's -4 times -3? 12. What's -4 times 6? -24. What's -4 times 6? -24. Hey, scalar multiplication, piece of cake. We're not going to do B for time's sake. But let me just tell you this. If they said 5b, then 5b is going to be a 5 multiplied times the b, right? And you just multiply every spot by 5. What if I said negative 2b? Then multiply every spot by a negative 2. What if I said half a b? Then multiply every spot by a half. Scalar multiplication, really easy. You're just distributing to every spot. Whether you work down a column and down a column or across the rows, it doesn't matter. Just be careful that you get to each element and you'll be fine. All right, that's matrices. Again, my advice is review that. Let's go through some statistics. All right, the mean. What's the common word for the mean? The mean is the average. Can't forget that. This is all review from pre-algebra. So if we were to do, so the mean is the average. I don't even know what I wanted to put in all that big blank there, but who cares? Right, we all know how to do an average. We sum up the numbers and we divide by the total number. So here is the notation for the mean or the average. It's a bar over top. We say X bar. X bar. Yo, X bar. So X bar means the mean. We did actually do that in pre-algebra, if you remember. And so I'm looking for the mean. Now, if you remember, I told you guys, whenever you're going to show me the mean, just show me the total on the top. So if I'm doing X bar, I'm doing the mean for the X data. Make sense? All right, somebody add up 99, 92, 92, 92, 88, 83, 79. As soon as you got that, raise your hand and tell me the value. 99 plus 92 plus 92 plus 92 plus 88 plus 83 plus 79. What do you got, Madison? How much? 625. Anybody confirm it? 625. Anybody else? Sam? Okay, good. So we'll consider it. You can stop punching. How many pieces of data? 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. That's 7, right? 1, 2, 3, 4, 5, 6, 7 pieces of data. So now just divide your 625 by 7. Who's got it for me? What do you got, Nick?
89.28.
89 point what?
28.
And what do we usually round to? Does it end at 28?
No.
All right, so when we usually round to one decimal place, right? So 89.3. Listen, I'm going to remind you of pre-algebra. Please look at the screen. If you make a bad round off and you tell me this is 89.2 and you do not show me this, you will lose all the points because I am not going to assume that you did everything correct. Now, if you show me 625 divided by 7 and then make a bad round off, I'll just take a point off for bad rounding. But if you don't show me what you did and you have the wrong answer, I'm not going to give you. I'm taking them all off because I don't know what you did. Right? If you remember, I always told you, show me the total divided by how many numbers. All right, median. You guys remember what the median is? Median is the middle piece of data. Middle piece of data. So sometimes the middle's obvious. Oh, by the way, well, we'll get there. Look at X. What is the median of X? That 92 is the middle piece of data. Do you agree? So 92. What about the median for the Y data? Most people want to average the 91 and the 77. You remember you got to average the two if it's an even amount of data? Why is it wrong to average the 91 and the 77? What did that person forget? To put them in order. They got to be in order. All right, so it's 91, 91, 87. I usually like to do this. 91, 91, 87, 77, 77, 75. Now I can average the two middle ones. So it's 87 plus 77 divided by 2. And everybody knows that that is an 82, right? So be careful if the data is not in order. And remember, if there's an even amount of data, you got to average the two middle ones, right? We all remember that? What's the mode? What's the mode? Say it if you know it. Okay, so some say the most often, but the word often is, this idea is the frequency. The most often occurring piece of data. Most often occurring data. So what's the mode of X? Clearly 92. What's the mode of Y? 91 and 77. Now you don't add them up. There's two modes for the Y data. What was the X? 92? 92. Okay, what if there's the same amount of every piece of data? Some people say every number is the mode. Some people say there is no mode. It's kind of boring either way. So it's really no bearing. There's like no significance if there's no mode. There's no significance. Okay, the range. You guys know the range is highest minus lowest. Highest minus lowest. So again, be careful. 99 minus 79. That's pretty easy. That's a 20 for the X. 99 minus 79 is a 20. Be careful with the Y. Again, you got to find the highest. That's a 91. The lowest is the 75. So it's 91 minus 75. So what is that, 16? 16. Okay. You guys remember stem and leaf plots? Now, there's no legend here. But remember, if I had a legend, it would go something like this. 2-1 equals 21. If these were decimals, I'd have to have a legend to let you know that. If there's no legend, you assume 30, 34, 37, 20, 21, 23, 10, 16, 16, 19, 5, 8, right? Remember that? First number is, the stems are the first digit. The leaves, stem is the first digit and the leaves are the second digit. Got to get them right, right? Stem is the first digit, leaf is the next digit. So that's how you do those. I'm not going to take the time to go through median, mode, mean, and range. But again, be careful. How many pieces of data do we have? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you wanted the median, you're going to have to average the 6th and 7th piece of data. If you can't figure out how to find the 6th and 7th within this setting, list all the numbers. Don't miss the question. Then list them in order. Do 37, 34, 30, 23, 21, 20, 19, 16, 16, 10, 8, 5, and then look for the middle if you can't do it the other way. Same thing with the mode. The mode is easy to read in the stem and leaf. In this one, the mode is what? 16. Again, I don't know why you guys weren't that quick to say that. So again, you're looking for the most leaves for any given stem, and that's 16. Again, the mean, you're going to have to add everything up. In the median I mentioned, the range would be easy, 37 minus 5, that's a 32. Okay, do you remember a frequency distribution? You got to remember that the first number is the data and the second number is how often. So you got to remember, this is saying we have 4 3s. I have 1 5. I have 1 6. I have 3 8s. I have 3 9s. Remember that? So be careful. The mode is very easy on these. What is the value of the mode? 3, because there's 4 3s. Now again, to find the median, be careful. There's 4, 5, 6, 9, 12 pieces of data. So again, you got to average the 6th and the 7th piece of data. So be careful. 4th, 5th. Oh, the 6th is a 6. So the 7th is an 8. So average 6 plus 8. What do you get? 7. That's going to be the median on this one. The mean, be careful. Here's where students get messed up. Remember how to do the mean? You got to add 4 3s. That's 12. Plus 1 5, 17. Plus 1 6, 23. Plus 3 8s, 31, 39, 47. Plus 3 more 9s. And then you got to divide by 12. Be careful with the mean on these. Be careful with the mean on these. You got to remember you have 4 3s. You have 3 8s. You have 3 9s, right? Remember? 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 We had all this. This is all review. What's the range? That one's easy. 9 minus 3 is a 6, right? That one was easy. 9 minus 3 is a 6. All right, and then I want to get to box and whisker plots. Anybody remember the name of the 40? Byron?
Outlier.
It is the outlier. Does every box and whisker plot have an outlier? No. It's a statistical anomaly. It doesn't fit the data. It doesn't fit everything else. Now remember, a box and whisker plot breaks up the data into percents. 25%, 25%, 25%, 25%. From the left whisker to the first line is the first 25%. From the box line to the middle is the second 25%, etc. Anybody remember what the red line represents? It's the what? It is the median. Red line is the median. What's the left whisker called? Lower extreme. Therefore, the right whisker is the upper extreme. All right, technically, the first line of the box is Q sub 1, or the first quartile. Don't get all caught up in that. It just simply means where the first quarter ends. And the end of the box is Q sub 3, or the third quartile. If I said what percent of scores are higher than 79, what would you say? What percent of scores are higher than 79? What would you say? Okay, if you don't know what to say, you really don't understand these, because these are really simple. What percent of scores are higher than 79? Look, folks, this is 25%, this is 25%, and this is 25%. Answer, 75%. I'm telling you, from the first whisker to the line of the box is 25%. From the first line of the box to the median is 25%. From the median to the second line to the right line of the box is 25%, and the last whisker is 25%. It's broken up in 25%. That's a really easy question. 75% is greater. What percent of scores are less than 79? 25%. You don't worry about the outlier. You guys remember how to do the interquartile range? It's the range of the box. 95 minus 79. It's the range of the box. This is box range. And therefore it would be a 16. Interquartile range, the range of the box. All right, I don't have time to answer the questions here. Why don't you guys do that, and we'll just review them tomorrow as we get ready for the test as well tomorrow and do test review. All right? Just answer those questions. I'm not going to collect it. Do it in your notes. And then we will go on and do chapter review tomorrow. Get ready for our test.